In this experiment, we are going to determine the wavelength of a light using the diffraction grating by minimum deviation method. This is another method. Previously, we discussed about the normal incidence method to calculate the wavelength of light by diffraction grating. In this video, we are discussing about the minimum deviation method. What is the minimum deviation? We come to know. First, we are applying the incident the light here, right? We are incidenting the light. You able to see we are incidenting the light. So this is the light is incidenting. Once you have to incident the light from here, this is the incident angle I, right? Some portion of part should be deviated. So the deviated angle is, what is that angle? D suffix m. How we have to get? First we are taking a direct reading. You have to take, this is the direct reading, right? From the direct reading, we are incidenting some light. So some portion of part should be from the direct reading, it is deviated. Such type of deviation angle we call it as a minimum deviation angle. How we have to calculate from the experiment, we come to know from this. What is the formula you have to see? 2 sin d by 2 is divided by n into n. Here n is equal to number of lines per centimeter on the grating. For a grating 15,000 lines per inch grating you have to take. Per centimeter is equal to 15,000 by 2.54 centimeter. Per centimeter these many slits are there. What is here? This is the order of the spectrum. Small n is order of the spectrum. So now you have to, first what we have to do? First we have to incident the light on the slit. Okay, so once you have to incident on the slit, what will happen? This slit is coming to this through convex lens. This is the convex lens. Through the convex lens, the slit may appear. The light is incident. The slit may appear through the convex lens. Correct. So this parallel slit, we need to incident on the prism table on a grating. We have to incident. Once you have to incident the grating, so now you able to see wherever the colors are coming. So those, when colors are coming, you have to see the eyepiece. So through this eyepiece you able to see the colors. So right here the light is appearing. This is the first order light is appearing. After appearing this, what we have to do? How we have to get the experimentally deviation method? First you lose this prism table, right? Through this screw you have to lose it. So this prism table, now you have to see the through your eyes, you able to rotate this prism table. You able to rotate this prism table, whether it may be clockwise or anti-clockwise you have to rotate. Suppose you have to rotate it anti-clockwise, you are rotating. So maybe your colors are like this. So maybe your slit is like this, right? These colors are moving like this. Once you have to rotate, after some time, these colors should be stopped and coming into this side and coming into clockwise direction. Whenever this color should be stop and return to the clockwise direction, that time you have to stop the prism table. Now you have to say how I am adjusting. This is the way, this is the slit. Now you have to rotate like this. After rotating, it is stable and it is coming into the clockwise direction. That time you have to fix it. So that time you have to fix it. Such type of fixing phenomena, we call it as a minimum deviation phenomena, right? Minimum deviation phenomena. Now you have to take the readings. So you have to take the readings for first order V1 and V2, and second order the left side V1 and V2 you have to take, and right side also you have to take the same way V1 and V2, and left side also you have to take the same way V1 and V2. So before going that, after taking this deviation readings, first you have to adjust this slit directly. You have to adjust. So direct slit you have to incident. You have to see that slit here. After seeing this, The direct reading V1 and V2 you have to take. Direct reading V1 and V2 you have to take from that spectrometer. After taking this spectrometer, how we have to calculate? Once you have to see. First V1, MSR is equal to 0. The least count is 1 minute is there. D1 is equal to 0 degrees. V2. So if it is 0, exactly V2 will come 180 degrees. That D1 is equal to 180 degrees. There is a 0 and 180 degrees is there. This is the exactly linear system. After this is the direct reading of the slit image. Slit image we have to take. Next, the angle of minimum deviation. The angle of minimum deviation values, for the left side we are taking the V1, for right side we are taking the V1. Now you have to deviate it from D2 to you have to differentiate with D1. So you have differentiate means subtract from D1, you are getting R1 value. The same way, this one you have to take it as a D3. This D3 also you have to differ with the D1, that is R2 it will come. So therefore you take the average value, that average value is D1, that is R1 plus R2 by 2 for vernier 1. Similarly, for vernier 2, left side you have to take, right side you have to take, that is the D3, the left side is D2. Now you able to subtract from V1 of the direct reading and the left side of the V2 reading. You have to differentiate. So they differ, you will get that R1, and same left side, right side V2 and direct reading V2 you subtract, you will get the, so D1 minus D3 R2 you are getting these deviation angle D1 and D2 for order 1. For order 1 you have to write this D1 D2. For deviation angle is equal to D1 plus D2 by 2, that is the deviation angle. So this angle you have to substitute in that formula. 2 sin d by 2 is divided by n into n. You will get the wavelength of the which light you are using, that light wavelength we are getting here. Similar fashion, for order 2 also you have to do. You are getting that value, that is the wavelength. Therefore, in the result you have to write the wavelength of light of a sodium vapor lamp. How much you are getting? Approximately near to 5893 angstroms. We need to get it. 1 angstrom is equal to 10 to the power of minus 8 centimeters, or 1 angstrom is equal to 10 to the power of minus 10 meters. So this is the experimental result. This way we have to write the wavelength of a sodium vapor lamp calculated by minimum deviation method. Clear? So whether you calculate through the minimum deviation method, whether you calculate through normal incidence method, whatever method it may be, you are getting the similar answer you have to get, because we are using the same source we are using. Which source we are using? Sodium vapor lamp we are using. That's why we are getting the same wavelength we are getting. Clear? So like this you have to do in your laboratory this experiment. Clear? So please share and subscribe and like our YouTube channel. Thank you.